right, let's talk Cisco ACI. It's an amazing platform, right? Super powerful. But with great power comes, well, some pretty confusing situations. You've probably seen it yourself. You've got one security rule saying go and another one screaming stop. So when your rules clash, what happens? How does ACI actually decide which one gets the final say? That's exactly what we're going to demystify today.
And really, it all boils down to this one question. When you have a bunch of rules all screaming for attention, which one actually wins? And let's be real, this isn't just some academic exercise. Getting this wrong can be a nightmare. We're talking about unexpected security holes popping up, or even worse, those mysterious application outages that take forever to track down. So yeah, figuring out this logic, it's absolutely crucial for building a network that's not just secure, but also predictable.
So here's our game plan. We'll start with what I call the rules of engagement, the basic logic ACI follows. Then we'll dive into some real-world battles, a specific EPG rule versus a wide-open DCACI policy. We'll also look at the deny action and how powerful it can be. And for the grand finale, we'll cover the ultimate trump card, the taboo contract. Sound good? Let's jump in. Okay, first up, the rules of engagement. Before we get into the nitty-gritty examples, we've got to understand the core logic. This is the foundation for how ACI looks at every single packet and makes a decision.
You know, at the end of the day, ACI priority boils down to one simple idea. Specificity is king. The more specific your rule is, the more power it has. So a rule you write for a very specific endpoint group, or EPG, is always going to beat a super broad catch-all rule for DCACI-A. Same goes for layer 4. A rule for a specific port, say HTTPS, will always win against a general IP rule. And sitting right at the top of this food chain, the deny action. It gets the final say over any permit. This is the basic hierarchy we're going to see again and again.
Okay, now, if you zone out for the rest of this, which I hope you don't, but if you do, remember this. This is the golden rule of ACI priority. The lower the priority number, the higher its actual enforcement priority. Think of it like a golf score. Lower is better. A rule with a priority of 5 will always beat a rule with a priority of 7, every single time. This is the Rosetta Stone for understanding everything else we're about to cover.
All right, let's put that golden rule to the test. Time for a real-world scenario. We're going to look at a classic ACI showdown, a super-specific EPG to EPG rule squaring off against a big, general DCACI-A contract.
So check out this setup. First, we have this really broad contract, a DCACI-A to DCACI-A rule. Basically, it's telling the whole VRF, hey, everyone is allowed to talk to everyone else using SSH. It's like an open-door policy. But then we add another layer. We create a much more specific contract, just between our web EPG and our app EPG, and this one says the exact opposite. No SSH traffic between you two.
So the big question is, which rule wins? The allow everyone rule or the block these two rule? Well, the cool thing is, we don't have to guess. We can just ask the hardware. A quick show zoning rule command tells us exactly what's going on. And would you look at that? Our specific deny rule between web and app, it gets a priority of 7. And that broad general permit rule, it's way down at priority 17. And the result? Well, it's exactly what our golden rule predicted, right? 7 is lower than 17, so the more specific EPG to EPG deny rule wins hands down. SSH between the web and app EPGs is totally blocked, even with that general permit rule floating around. Specificity for the win. That last example was perfect because it tees up our next big topic. The incredible power of the deny action. See, this isn't just about breaking ties between conflicting rules. Using deny strategically lets you design your security in a totally different way, a way that's often a lot cleaner and more efficient. And you can see it right here in the APEC. When you're building a filter, you've got this little drop-down for the action. Most of the time, we just leave it on permit, right? But you can explicitly flip it to deny. It looks like such a small thing, but trust me, that little toggle has massive implications for how you build your policies. So why should you care? Well, because it can make your life a lot easier. Think about it. You can create a really broad permit policy, maybe using DCACI-A to let things talk by default. Then you can use these high-priority deny actions to poke very specific surgical holes in that permissive policy. It's just a cleaner way to build a block list model. It's way easier to manage. And hey, as a bonus, it can even save precious TCAM space on your switches. Now here's where it gets really cool. The priority of a deny action isn't set in stone. You can actually tune it. As you can see in this table, you can give it different levels of, well, oomph. If you set it to highest priority,
ACI gives it a numeric value of 7. Sound familiar? That's the exact same priority as a specific EPG to EPG contract. This makes it a super powerful tool for overriding other rules with precision. Okay, but what if you need something even stronger? What if you need a rule that is an absolute ironclad thou shalt not pass kind of block? For that, my friends, we have the final veto. Meet the taboo contract. This is ACI's ultimate trump card. You'll find taboo contracts right under your tenant's security policies. But here's the key difference in how they work. You don't apply them between a provider and a consumer like a normal contract. Instead, you apply the taboo directly to an EPG. It's like building a moat and a giant wall around one specific EPG. You're turning it into a fortress. And this is the secret to its power. A single number, 5. A taboo contract always gets a hardware priority of 5. And remembering our golden rule, lower is better, what does that mean? It means it will beat a standard EPG to EPG contract, which usually has a priority of 7 or maybe 9. Priority 5 is designed to win. So let's see it in action. In this scenario, we've got a standard contract between our web and app EPGs that basically says permit all IP traffic. The door is wide open. But we've also slapped a taboo contract directly onto that web EPG, and its only job is to deny any and all inbound SSH traffic. And once again, we turn to the CLI for the ground truth. And there it is, clear as day. Look at that rule ID, 4205. You can see the deny action from our taboo contract, and look at its priority. The hardware literally calls it black_list 5. I mean, come on, that rule was born to win. So the result is, well, absolute. With its unbeatable priority of 5, the taboo contract wins. It completely blocks all inbound SSH traffic to the web EPG. It doesn't care what other contracts you have in place. The taboo contract gets the final word. End of story. Okay, that was a lot to take in. We've gone through the rules, we've seen the proof in the hardware. So let's wrap this all up. Let's boil it down to a few key design principles that you can start using right away. So here are the big takeaways. Number 1, and I'll say it again, our golden rule, lower priority number equals higher enforcement power. Simple as that. Number 2, specificity is your friend. A direct EPG to EPG rule will always overpower a general vZiny policy. 3, don't be afraid to use the deny action. It's fantastic for creating clean, block list style policies. And finally, when you need the ultimate hammer, the taboo contract, with its unbeatable priority of 5, is your go-to tool for an absolute block. Look, at the end of the day, this isn't just a bunch of theory. This is your toolkit for designing better, smarter networks. Once you really get this hierarchy, you have incredibly precise control over your traffic. So I'll leave you with this question to think about. Now that you know how it works, how are you going to use this priority system to build more secure and more predictable policies in your own ACI fabric?